In this video, I'm going to focus on the formation and properties of images in concave and convex mirror. In my previous video about mirrors, link below, I explained how to use ray diagrams to show the formation of images. Okay, let's go through the first example, that the object is beyond the center of a concave mirror. Don't forget to always use a ruler and a pencil. Okay, first step is to draw a concave mirror. Then we draw the principal axis, label center and the focal point, and then we draw our object that here should be beyond the center, and we show it by an arrow. For finding the image, you need at least 2 incident rays. I always use one incident ray that is parallel to the principal axis and is always reflected somehow that pass through the focal point. Okay. And second one, if it goes through pole of the mirror, that is here is pole, is reflected back somehow that the angle of incidence should be equal to the angle of reflection, as we know based on the law of reflection. Okay. The part that 2 reflected rays cross, that part is the image of our object. And as you can see, the image here is between center and focal point, and because it's in front of the mirror, it's a real image, is inverted, and is a little bit smaller in size than the object. So we write the property of image here. Okay, so the image is reduced in size between C and F, inverted, and is real. Okay. Right now, let's go through another example. This time, we put the object at the center. So again, same step, we draw our mirror, principal axis, center, F, and our object. That here is the center. Then again, we need 2 ray diagram, 2 incident ray that parallel one reflected through our focal point, and the second one, same angle. And you can see the part that 2 reflected ray cross is our image. And you see image also is at the center. So the property of image here, we can say is same size at the center. As seed center is this point, not here. So here is the center, and inverted, and definitely it's real because it's in front of the mirror. Right now, let's move the object a little bit closer to the mirror. So we put the object between center and focal point. Again, same step, and this is our object. So incident ray parallel to the principal axis, definitely is reflected back somehow that goes through focal point. And the second one to the pole reflected back, and as we can see, the angle of incidence, that is this one, should be equal to the angle of reflection, that is this one. So again, they're cross in front of the mirror, so definitely the image should be real. So as you can see, the image is beyond C. Beyond C, is a little bit larger, is inverted, and is beyond the C, larger, inverted, and is real. And then we put image in front of F. Again, same step, and we put image in front of F. I haven't explained what happens if we put image on the F. Actually, if we put image here, we can't get any image because the reflected ray are parallel. And as a result, they never cross each other. So it can't make any image. Because of that, we didn't discuss that. So we put the object just in front of F, and we follow same step again. 2 incident ray, 1 parallel that reflected back somehow that goes through the focal point, and the second one. And you can see, as you can see here, they are diverging. So if I just extend this one here, you can see they never cross in front of mirror. But maybe if we extend this one behind the mirror, maybe they can cross. Let's try. So as you can see, at the back of the mirror, 2 reflected light can cross. So the image of this object, the tip of this arrow actually is here. So the property of image, as you can see, is at the back of the mirror, is definitely larger, upright, but as it's the back of the mirror, it's not a real image, it's virtual. So you can't have it on a screen, you see it in the mirror. Okay, right now, let's discuss images in convex mirror. So in a convex mirror, as you know, the other name for convex mirror is diverging mirror. As the reflected lights from convex mirror never cross in front of the mirror. So as a result, they always form a virtual image. So definitely first step is drawing our mirror, but this time is convex mirror, principal axis. And remember, focal point is at the back of mirror for convex mirror. We put our object and 2 ray of light. We use 1 parallel one, but remember the parallel light reflect in a way that its extension will pass through the focal point. So it's reflected back, but its extension can go through focal point. So you see they are diverging, 2 reflected ray diverging, and it's something that we expect as convex mirror is diverging mirror. So they never cross in front of the mirror. But what about just extending them beyond the mirror? So as you can see, the parallel light reflected back somehow that its extension actually passed through focal point. This point that these 2 reflected ray cross is the image. And as you can see, the image is smaller at the back of the mirror. Definitely because it's at the back of the mirror is virtual and it's upright. Just a small comparison. Remember, when you have a convex mirror, you always have a virtual image that is smaller than object. But when you have a concave mirror, just in one case, that your object is in front of focal point, you have a virtual image, but that virtual image is larger than your object.